So let's get started with 7.3, additional items involving solutions to equations. And that doesn't sound like much fun, but this lesson really isn't too bad, and it does really help you later on when you're doing math to be able to know what's going on here. Now, if you remember, in the last section, we did x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that was the formula, the quadratic formula that we used. And there is a certain piece of this quadratic formula called the discriminant. Sorry about my handwriting, that is a C. The discriminant. The discriminant is this bit of information under the radical sign. So basically, the discriminant is b squared minus 4ac. Now, when we're given just the discriminant and we're given an equation, we can determine based on just this what kind of answers we're going to get when we use the entire quadratic formula and what kind of answers we get, because we've got this radical sign. So let's say that we've just got numbers and we're putting them in for a, b, and c. If the discriminant, the number, once we do the b squared minus 4 times the a value times the c value, once we get an answer here, by taking the square root of that, that'll tell us what the rest is going to do. So let's say, for example, that we put numbers in here for b squared minus 4ac. So, well, let's just try one. Let's say that I give you the equation x squared minus 3x minus 40 equals 0. So if you remember, this is your a, this is your b, and this is your c. So if we just plugged in those numbers here, we would get b squared. So we'd get negative 3 squared minus 4 times a times c, which is negative 40. And if we did the math, we'd end up getting 169. Okay. When we take 169 and we put it in here, according to the quadratic formula, we are going to take the square root of whatever number we get for the discriminant, in this case 169. Square root of 169 is 13. So it doesn't matter what this is, plus or minus 13 over 2 times, in this case 1. Doesn't matter how all this works together. All we know is the square root sign disappears, which means that we get 2 answers because of this plus or minus sign, so negative b plus 169, or I'm sorry, 13, or negative b minus the 13 over 2 times 1. So the answer we're going to get when we can take the square root of the number that we get when we plug in all the numbers over here for b squared minus 4ac, when we take the square root of it, if we get a regular old number, a counting number, a whole number, I should say, because it could be, well, it would have to be counting numbers greater than 0. We will get 2 answers. Sorry, it's been a long time since I've written. 2 answers, and they will be rational numbers. So when we plug everything in there and get an answer, we'll get 2 answers because of the plus or minus sign right here. Whoops, wrong pen. Because of the plus or minus sign here. And those numbers will be rational numbers. There won't be any square roots. There won't be anything really goofy. It won't be imaginary numbers or anything like that. That is when this number here equals what is called a perfect square. In this case, it was 169. A perfect square is when you can take the square root of that and get a rational number here. You're not getting a fraction or a decimal or an imaginary number or anything like that. So when we get a number you can take the square root of, we know that we're going to be able to get, when we plug this in for the whole quadratic formula, we're going to get two answers, and both of those answers are going to be rational numbers. Let's say, for instance, let me erase all this junk here, and we will keep our quadratic formula there. If our b squared minus 4ac is, let's say, for instance, let's say that when we solve this, we get a negative number. So, for instance, if I had the equation 2x squared minus 3x plus 4 equals 0, and we plug our numbers in, so we get negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a, which in this case is 2. Okay, so that is putting in all the numbers into the quadratic formula. Now let's look and see what this is going to give me if I were to just look at the discriminant. I'd end up getting, I'll do this in blue, negative 23. So now I've got negative 3 plus or minus the square root of negative 23 over 4. So I've got a negative 23 there. You cannot take the square root of a negative number. So if you remember in the past, whenever you see this negative number, we turn it into an I and we pull it out of the radical sign. Okay? That means now our answer is going to be, let's go ahead and make that a plus 3, plus or minus I square root of 23 over 4. That is not very pretty, but we get 3 plus I square root of 23 over 4 and 3 minus I square root of 23 over 4. This is not a rational answer. This is a complex solution because it contains I. So whenever your discriminant equals a negative number, you still get two answers, but you have I in the answer. And sometimes when you're doing these problems, it's very important to know before you solve all of this mess here, it's nice to know what this is going to be, because sometimes you can stop doing the problem at that point because you know, having an I, this is not something I can graph. So I'm wasting my time to continue on. So it does give you some information, and as you get further and further into math, you'll find out how important that information is. All right, so that's what happens if the discriminant is a negative number. And I'm looking at page 598 in the middle of the page in the purple. Notice the first column says negative. So if the discriminant is negative, you get two complex solutions containing I. The other one we got a positive number that is also a perfect square, which is the third one down, and we get two rational solutions. Okay, if we continue on, and let's say that we use, looking at number 3 at the bottom of page 598, 4x squared minus 12x plus 9 equals 0. And if I put those numbers into just my discriminant here, I end up getting negative 12 quantity squared minus 4 times 9, and that gives me 144 minus 144, which equals 0. So that means that number that is going to go under the square root sign is a 0. Square root of 0 is 0, and because that's the case, we have negative b plus or minus 0 over 2a. Well, plus 0 and minus 0 does not change your answer. So basically what you're getting here is one answer, and that one answer is rational. So for instance, if we use this equation right here, we would end up with negative 12 plus or minus the square root of 0 over 2 times 4. So 12 plus or minus 0 over 8. Well, 12 plus 0 is 12. 12 minus 0 is 12. So you get two answers, but they're the same thing. So you get 12 over 8 because you added 0, and 12 over 8 when you subtracted. So basically the same answer. So one rational solution. The next thing you're going to get is, let's say that you put the numbers in here, but instead of 0, you get a positive number in here, but it's not a perfect square. Remember the last one we got, or earlier we got 169. That's a perfect square because the square root of that is 13. But let's say we got square root of 17. That is not a perfect square. You can't take the square root of it. So you still get two answers, but your answer is a irrational number. So you get two irrational numbers if the number under the square root sign you cannot take the square root of. So that's what we're looking at. So all that to say, and this is a fairly short lesson, but it does take a little bit to give you all the information necessary to do these problems. So not really too hard in the problems they give you. In fact, let's look real quick and look at something like number 5 on 603. So we have x squared plus x minus 1 equals 0. So we're using negative b plus or minus square root of b squared minus 4ac all over 2a. Do you have that memorized yet? Okay, so this is my a, 1, this is my b, and this is my c, negative 1. So I'm going to just look at the discriminant. You don't have to do anything else. So b squared minus 4ac. So b squared would be 1 squared minus 4 times a, which is 1, times c, which is negative 1. So 1 plus 4 equals 5. So 5 is the number that goes under here. Now, if you look back on page 598 and look at that little graph there, or not graph, but table, that purple table, in it, what is 5? 5 is a positive number. Is it a perfect square? No. So what does it say? A positive number that is not a perfect square gives me two irrational solutions. So that's what they want for the answer for numbers 1 through 12, and this one specifically for number 5. They want you to write the answer is 5, and it is the answers are going to be two irrational solutions because the positive number is not a perfect square. So that's what they want for numbers 1 through 12. All right, so let's jump to letter B, and then we'll do C, and then we'll be done. And it'll probably take me 2 videos to do that because, like you know, I have a tendency to kind of ramble here. So what they're asking for, find an appropriate K so that the equation, let me get black here, 4x squared minus kx equals negative 9. So we're trying to find the value of k so that we get one rational solution. So if we look over at page 598 in that purple table, one rational solution is in the right-hand column, and that means that the discriminant has to equal 0 in order for that to happen. One rational solution in the column on middle of page 598 means that our discriminant has to be 0. So A is 4, B is negative k, and C is 9. Okay, because we're going to add 9 to both sides and get plus 9 over here, and then this will turn into a 0. So we have to have it in this format first, and I apologize I didn't do that right away. Okay, that being the case, now we can put the numbers in our discriminant. So negative k, we just pretend it's a number, minus 4 times 4 is our A times our C, which is 9, equals 0. So negative k quantity squared equals 144. 4 times 4, and then that times 9. Okay, so, oh, I'm sorry. Why did I put an equal sign? I needed to have a minus sign there, didn't I? You probably caught that, and you're wondering what in the world I'm doing here. All right, so k squared, because negative k quantity squared would be the same as k squared, minus 144. And if we set that equal to 0, and we take k squared equals 144, take the square root of both sides, k equals plus or minus 12. So if we did all this work here, we get a 12, a positive 12 here, or a negative 12 to put in here. That will give us a discriminant of 0. So in order to get a discriminant of 0 so that we get one rational solution, I have to put 12 in here. So do you follow what I did there? All right, so we're going to do something kind of weird here, and I'm going to do this in a new video. So get ready for part B.